Hello, this is Mr. Agbamu Idonogrene. I'm here to teach mathematics on the topic latitude and longitude. In today's class, this is our objectives. Number one is to state the radius of great circles, calculate the radius of parallel of latitude, and calculate length of parallel of latitude. In our last class, we tried to look at how to get the angles between two points on the Earth's surface or on the sphere. And we said to do that, all you just need to do, you locate the 2 points first. Then after locating the 2 points, the next thing is to get the longitude and the latitude so that you can know where the angle is positioned. So if you follow our last class very well, you understand that and it's not a problem. In this class, we are trying to look at the radius, because the next thing is how do you calculate the radius of great circle and parallel of latitude. Remember what I told you before. In this topic, our major target is how do you get distance between 2 points on the surface of the earth. And if you must do that, you need to know the radius that you are going to use, and you need to know the angle between the 2 points. If you know that, then the next thing is to use length of an arc formula and you are okay. But today we are not going to calculate anything distance yet. I want us to focus on the radius, just like how we focus on distance between 2 points in our last class. Okay, let's look at this. For the radius of the Earth, which is also called the Great Circle, radius of the Great Circle, the radius is approximately given as 6,400 kilometers. So this is an approximate value given down by scientists over the years. So this is what we use most times in our calculation. Even in your WAEC exam, most times this radius will be given. But if it's just a sphere, not the Earth, they will also give you the radius that you will use. But the most important thing is that sphere, you need to know the radius of the sphere, because that will give you the great circle. And that radius of the great circle is the same thing as radius of the equator. So by now you should know what equator means and what great circle means. So if you know that, the next thing is radius of parallel of latitude. So this is where I want us to pay attention. Though the formula is direct, radius of parallel of latitude is given by, we use small letter r to represent radius of parallel of latitude, and it's usually given as capital R, which is the radius of the great circle, and radius of longitude or radius of equator, which is capital R, times cos alpha. So this alpha is the latitude. You can see what it means here. I say where capital R is radius of the Earth, which is 6,400 kilometers, then alpha is angle of latitude. So before you can get the radius of any parallel of latitude, you must know the angle of that latitude. It is the angle of the latitude you will find the cos of that angle, then multiply with the big R, which is 6,400. Then you cannot get the radius of the small circle. But let me just demonstrate it, how this formula came about. You need to know it. Let me show you this animation. So this is a sphere that we usually use to represent the Earth's surface. So you can see the north here, the North Pole, and you can see the South Pole here. Okay, and this is the polar axis, the line that joins North Pole to South Pole. You can see it at the center. Okay, so you can view it very well. I want you to study this shape. Then another two important line is the two reference lines, the equator. So this is the equator, the horizontal line, you can see it. Then this is the prime meridian. So these two lines are our 0 degrees. So take note of that. Then the radius we are talking about is the radius from the center. You can see the center of the sphere, which is represented as center of the Earth, to the circumference. You can see it to this point. See, so that radius is what we label as capital R, like this blue angle here, like this one. So the blue angle from the sphere to the center, you can see it, the radius is capital R. Then this is the parallel of latitude, you can see it, and this is the angle we represent as alpha. can see it. You can also see this one. Let me position it here. In this case, the angle is 48 degrees. So you can see it. And because the parallel of latitude, remember in our first class we say parallel of latitude, they are all parallel lines. They are horizontal lines or line that runs from east to west, and they are parallel to the equator. So you can see that from the center of the earth to the equator, you can see the line is this angle alpha, and that is the alpha we need in our calculation of radius of parallel of latitude. So this angle alpha in this case is 48 degrees. You can see that it's also equals to this angle also from this parallel of latitude to the center of the earth. So you can view it well like this, or let me turn it like this so that you can see it. So this is the alpha and this is the alpha. You can see that both of them are equal. You can see it very well. Just trying to put it in different views so that you can get it well. Then the radius is this blue line, radius of the earth. I want you to see it very well. Then this radius of the parallel of latitude, which I use red line to represent, which is small letter r. So by the time you get this picture, you see that to get the parallel of radius of parallel of latitude will not be an issue. So these are reference. These are reference. So if you can move this one, you can see it. So the parallel of latitude can change. You can see. Now that I put it on the equator, you can see both of them are equal now. You can see the small letter r is equal to capital letter R. You can see the blue line have even disappeared. You can see it because I've moved the parallel of latitude to be equal to the equator. You can see it here. So small r is equal to the capital R. You can see. So I can also move it down to south. You can see it. You can see. You can move it down to south. So when you come down to south here, let me put it on this side. You can see the radius of the earth. This capital R, the blue line. You can see the radius of parallel of latitude. Then you can also see the alpha, the angle of latitude from the center of the earth to the circumference that forms the parallel of latitude. If I put it under like this, I think you can see it clearly. This is towards south. You can see the radius of parallel of latitude. So this is the radius we are talking about, radius of parallel of latitude. Then this radius of the sphere. Alright, now that we have viewed it in so many directions, I think we are okay like this. So I'm taking it back to the North Pole. You can see the radius. You can see it very well. Okay. So take note of this. So with this shape now, if I view it like this now, let me put it in this direction. So this is what we have on paper. This is what we have on paper. If you want to understand it very well. So you can see it. So we have this shape. So this angle here, you know, is 90 degrees. Let me put it so that you can see it very well. Okay. So this angle is 90 degrees. You can see the symbol of 90 degrees. So this is angle 90. So this is 90 degrees. So this is radius of parallel of latitude. Then this is the angle radius of the sphere, capital R. Then this is the latitude itself. In this case, this is 45 degrees. And we use alpha to represent it. So because this angle is equal to this, you know, these alternate angles. This angle is equal to this angle. That is alpha is equal to this angle alpha. So since they are equal, what do you do now? We need to use our SOHCAHTOA techniques. Remember, this is a right angle triangle. See, this is a right angle triangle. So with your knowledge of right angle triangle, all you just need to do is, this is the angle we know now, which is equal to the latitude. So this angle, you know it. So all you just need to do is, your target is to find R. So if you use SOHCAHTOA now, which is cos, adjacent over hypotenuse. Remember, this is where the angle is facing. This side is opposite. This is angle 90. This side is hypotenuse. Then the remaining side is adjacent. So adjacent, small letter r, over hypotenuse will give you cos alpha. Then when you make r a subject, you will get the formula we just got in the explanation. Okay, let's go back to our write-up. So this is what we are talking about. So all we did here to get the formula is not difficult. It's just this. Remember the sketch we have the other time. Let me sketch it here. Something like this. Something like this. So this is the angle 90. So this is the kind of sketch we had the other time. So this side, this is the alpha. This is the alpha. Then this small letter r. This is small letter r, and this side is the capital R. So when you now say cos of this angle, the cos of this angle is going to be adjacent over hypotenuse. So let me put it down in write-up so that we can see it. So if you use cos, this symbol here, alpha, which is, let me get this symbol. If you use cos alpha, the cos alpha is going to be equals to small letter r divided by capital letter R. So this is it. You can see it. Okay. So that's what we did. Then how did we get this final small radius? Just cross multiply. So when you cross multiply, you are going to have small r is equals to capital R, which is radius of the earth, times cos alpha. Let's put the alpha there. Okay, cos alpha. So that is it. So this is how we got this formula. Take note of it in case you want to derive it. That's why I did all this. So take note of this. Okay, before we go straight to example, I want us to look at this very example. It will help us very well. Okay, let me remove this sketch we had here. Okay, so I want us to look at the objective again. I said calculate length of parallel of latitude. Calculate length of parallel of latitude. Let's say now that you know the radius of parallel of latitude, which is small r, is equals to capital R, which is this 64, that's 6,400 times cos of the latitude. It will be given in all calculations. So take note of that. Then by the time you know that, then how do you calculate length of parallel of latitude? And this is where we are going to stop in our class. It's very, very important. Some questions usually come out in WAEC question. You can see this example we have here. This is a WAEC question, very important. But let's study the how do you get length of parallel of latitude, which I represent as L. So the length of parallel of latitude is the circumference of the parallel of latitude. It is given by L equals to 2 pi r. Remember, length of parallel of latitude is the same thing as circumference of the parallel of latitude. Remember this sketch. See it. This is latitude now. You can see it is parallel to the equator, the bigger circle. So it's a circle. Then if you want to get the total length on this parallel of latitude, all you just need to do is get your length of circumference of a circle, which is 2 pi r. That is it. Because there are some questions. Let's study the example. We'll come to this sketch. You understand what we are talking about with the example. Okay. So this example says we should calculate. It says WAEC 1998 number 17 is an objective question. Take note. It said the radius of a geographical globe is 60 centimeter. So this globe is sphere, normal sphere. So the radius is 60 centimeter. The question says find the length of the parallel of latitude 60 degree north. Now I told you that they must give you the latitude if they want you to get radius of parallel of latitude. So they want you to find the length of the parallel of latitude. You see now, if you don't know how to get the radius of parallel of latitude, how can you get the length? You see, because the length of parallel of latitude is 2 pi r, and r is the radius. Then how do you get the radius? In our previous class, in our previous session, let me just write up so that you can see it. In our previous session, we said the radius of parallel of latitude, you can see it, is equals to capital R, which is the radius of the sphere itself. So if it's Earth, we use 6,400 times cos alpha. And remember I said alpha means angle of latitude. That is all. It's a very simple question. But if you don't understand it, you just be there looking. So how do we solve this question? First, we need to get the radius of latitude. So you start with the capital R is equals to 60 centimeter. That's 60 centimeter. Then small r is equals to capital R cos alpha. Get your symbol cos alpha. See it. Then what is alpha? You can see alpha is the latitude given. Then alpha in this case, alpha is equals to 60 degrees. So by the time you bring out your data like this, you will have no problem while solving such a question. Okay, so you can see the three important information: capital R, small r, and alpha. So this is the radius we need, radius of parallel of latitude. If you know the radius of parallel of latitude, the length will be easy because the length is 2 pi r. Very simple question. Then now that we know the capital R at 60 degrees, which is the radius of the globe itself, then we know the alpha, which is the latitude of that parallel, the angle of latitude of that parallel of latitude, which is 60 degree north. Then what do you need to do next is just start small r is equals to your capital R is 60, then multiply by cos. So 60 times cos, the angle there is 60 degrees. So that is all. Then you evaluate with your calculator. Then R is equals to 60 times, so cos 60 should be what now? Cos 60 should be 0.5. But let's check with our calculator in case you are doubting. Cos 60 will give us, you can see 0.5, which is 1 over 2 or 0.5. So cos 60 is 0.5. Okay, now that we have checked the answer is 0.5, you just put it there, 0.5. Then when you multiply 60 times 0.5, that is R is equals to 60 times 0.5. We can do that one here. 60 times 0.5, this will give us 30. So the answer is 30. So 30 centimeter. So 30 centimeter is the radius of that parallel of latitude. So take note of that. So now that we know the radius, so you can get the length. You can now say therefore length is equals to 2 pi. The length is 2 pi r. 2 pi r. And it will be easy for us to calculate now. So L is equals to 2. So if pi is given, you can use 22 over 7. If it's not given, depending on what the question wants. In this question, pi is not given. You can leave your answer in terms of pi if you like. Understand? You can leave it in terms of pi, depending on how the question comes. Then, or you put 22 over 7. It depends on what the question wants us to do. But let me leave it in terms of pi. It's just an objective question. You can see then you have 2. That is 2 times 30 will give us 60. So the answer is 60 pi. So the answer will be 60 pi centimeter. So that is it. That is the solution to this example question. You can see that it's not a difficult one. The radius of the globe is 60 centimeter. Find the length of parallel of latitude of 60 degrees. So you already know that from the center of the earth to the circumference is the capital R, which is 16 centimeter, which is something like this. You can see it. So the radius of the globe, so this is the globe now. You can see this full sphere, and that's what I use capital R to represent. So from the center of this sphere down to the circumference, this is 60 centimeter in the question. Then this is the question this is the small r we calculated first by multiplying capital R by this angle given. This angle in that question was given as 60 degrees, something like this. If you continue to rise up, so you can see something like this. It's given as 60 degrees. So this is what they gave in that question. Then this is the circumference they want us to calculate, the length of parallel of latitude. Let me turn it. See it? So it is this circle. They want you to get the circumference of this circle, but they won't tell you. They will just only say calculate the length of parallel of latitude. They expect you to know this, have this basic idea. This is what they expect you to know. That is it. You can see as this angle is changing, as the latitude is changing, this radius is also changing. You see, as this latitude is changing, the radius is changing. If I bring this one down, you can see as the angle is changing, you can see the angle. See this angle as it's changing. Now that is 19 degrees, you can see that the radius is big. You can see the radius is very large. So you expect to see a larger circle. You can see it very close to the equator. So take note of this. It's very, very important. So before we go, let's try another example. Let's try another example before we go. Let's look at this example. So this one is also a good one for practice. The question says we should calculate the speed of point M on latitude 45 degrees south due to the rotation of the earth. So now they want you to know the speed, calculate the speed of point M on latitude 45 degrees south due to the rotation of the earth. See, this one is earth they gave. So the radius you can see is given in bracket. Take pi as 3.142, take radius as 6,400. But what they want you to find is the speed of this point M. On this point M is standing on latitude 45 degrees south. So how do you know this? Get the speed of this point M. That's what they want you to. Let me just demonstrate this question. You see what they are saying? It's just like this very point now. This very point. Like this very point. This is the point they're talking about. So this point that I'm moving around this sphere now is down on the south direction. That's what the question is talking about, 45 degrees south. So if I put it like this, you can see it. You can see, so this point, let's take this point now as the point M. Let me turn it like this so that you can see it well. See, so this is the angle 45 now. See, this is the 45 degrees. So from the center, it turns 45 degrees south. So this point here, this is the point M. So this is the other angle here, 45 degrees south. But this small radius, you need to know it first. This is the radius of, if I put it like this so that you can see it. So we need to know this radius, this small letter r, we need to know it. If we know this radius, then we can get the length of this small circle using 2 pi r. If we can get the length of this circle 2 pi r, then we can use our formula for speed. So this is just the sketch of that question. I want you to understand it very well. Then if point M, this is the point M now, this very point here. If this point, let me get the label of this point so that, let me name it. Okay, let me name it point M so that we can see what we are talking about. Okay, let me bring the name out. Okay, let me bring out the name. Okay, the name should be there. Okay, the name is there. I've seen it. Okay, look at it. You can see the M. You can see M there. Or let me change the color so that you can get it bright. Let me use a very sharp color to label it. Let me use something like red. I think it's well pronounced now. Okay, so this is the point M. So the question is saying like this: if this globe is rotating, you can see how it's rotating. Let me try to rotate it slowly. See if I can make it turn slowly. Okay, you can see how M is turning. See how the point M is turning on latitude 45 degrees south. See how it's rotating. This is what the question is telling us to do. So point M is rotating. You can see it is going round. So let's go back to the question and see. So it says calculate the speed of point M on latitude 45 degrees south due to the rotation of the Earth. So that is it. You can see as the Earth is rotating, what is the speed of this M as it's going around on this latitude? So that is just it. That is all about the question. You can see. So what is this speed? So how do you calculate this speed of M as it's going around? You understand? How do you calculate the speed of M as it's going around? See, how do you calculate the speed of this M as it's going around? I want you to sit in another direction. So as it's going around, how do you calculate it? So that's what the question is talking about. So it's not really a difficult one. Number one, all we need to know is speed. From our basic science, we know that speed is distance. Speed is distance divided by time. This is the formula for speed. Take note of that. So speed is distance over time. But in our case, in this our case now, distance we are going to use here, the distance we are going to use here is the circumference of the circle, because the circumference is point M is going around the circumference of that circle. So our distance we are going to use here is going to be 2 pi r. 2 pi r. So that will be our distance. Then divided by the time that we use to go round. So that is just it. The speed will now be 2 pi r over time. Since 2 pi r is the distance round the latitude where M is standing on. So this is the formula we are going to use. So let's bring out the given data so that we can see what we are going to do. If I start with, okay, let me start with T. So how do we get our T? So to get your T now, you know M is going around, is rotating around the Earth, and we know from our basic science also that the Earth rotates, the Earth takes 24 hours to go around its orbit. That is 1 day. 1 day is 24 hours, which is 24 hours. So that is our time. You understand what I'm talking about? It's very, very important. The Earth rotates. For a day to be formed, M, when M turns round like this, when it goes round, when M goes round, complete one rotation. So just take this mouse, let's take where this mouse is located as a point. So this is as you go round and come back to this place, that is 24 hours. As you go round and come again, 48 hours, just like that. As you go round, 72 hours, that is 3 days, it continues like that. So 4 days. So this is what we are talking about. So since this question is just on a single rotation, calculate the speed of M on latitude. This is due to the rotation of the Earth. So when the Earth rotates once, it takes 24 hours for M to go around the circumference, to go around the orbit and complete one oscillation. That is one rotation. So T is going to be 24 hours. Then we need our R. So how do we calculate for R? We have already proved that in the other section of our calculation that R is capital R cos alpha. That is the latitude that is given. Just take note of the formula and you are okay. So if this is R, then how do we solve for R now? It's not a difficult thing. So R is equal to, we have given capital R as 6,400, and you multiply it by cos of this angle 45, which is cos 45 degrees. Then let's solve and get this answer. That means R is equals to, so we can also use our calculator to check, but let me put down 6400 times. So what is cos 45? Let's check with our calculator. So cos 45 is going to give us 0.7071. Okay, let's take it to 4 decimal. 7071. That is the cos 45, 0.7071. Then the next thing is to multiply with R. So R is equals to, you can do that calculation here, 6,400 times 0.7071, which is equals to, let's put it in decimal form. So you have 4,525.44 kilometer. No, the radius is given as kilometer, so your answer is going to be in kilometer. So now that R is known, we are through with our calculation. Just solve for your speed now. Now say therefore speed is equal to, so 2 pi r, which is 2 times 3.142 times radius is now 4,525.44, then divided by the time, which is 24. That is all. If you simplify it well, I can do that one here. Can do that. So let me just simplify everything directly and get our answer. So 2 times 3.142 times 4,525.44 divided by 24 hours. So we are going to get that and put it in decimal. So our answer for speed is equal to 1,184,911 kilometer. Remember, time is in hours, so kilometer per hour. So that is the answer. So that is it. Kilometer per hour is our unit. So take note of that. So this is the second example. So take note, this for calculation of speed. These are the two major calculations you may be asked in this topic. Speed of rotation of a point, or you calculate the length of the parallel of latitude, length of the latitude. By the time you know these two approach, I'm telling you the truth, every other thing you will be asked in this topic will be very simple. So in our next class, we shall do distance between 2 points. That is the major thing WAEC focuses on in their exam question. So I think you enjoyed this class. Let me just revise what we did today. Take note, we started by saying radius of the earth is 6,400 kilometers. Then we see radius of parallel of latitude is given as small r, which is capital R, which is radius of the earth, 6,400 times cos alpha. This alpha must be given in all questions. That is the latitude on which, the angle of latitude on which that parallel of latitude is located. That is alpha. So you can see the meaning angle of latitude, and we did the derivation of how we got it. You saw the analysis there. You can go through the video again to understand it. Then we now look at length of parallel of latitude. That is just normal circumference of a circle, 2 pi r. Then from there we now solve these two examples, this wire question. Say we should find the length of parallel of latitude when the latitude is 60 degrees. We should get the length of that latitude 60 degrees, then the radius of the sphere is 60 centimeter. Then following the step very well, see the answer. Then pi is not given, so I left my answer in terms of pi. But if pi is given, you can substitute the value of pi and multiply it by 60, you will get the result. Then finally, the example we did before we stop now is this. Speed is what they want us to calculate of a particular point. This point M is standing on this latitude due south. That means it's going around the earth is rotating at point M. So what is the speed at point M? So all you need to do is to get the length of that point. If you know the length, time for rotation is 24 hours per rotation. That's 24 hours in a day. So that's why we took t as 24 hours. So if you solve it well and you substitute, you will get this answer as your speed. So by the time you are through with this, you see that this topic we are really progressing well. It's not a difficult topic. Then before we go for today, just practice these two questions. They are very nice. So you can see them. First one is to calculate the speed of point G on latitude. It's similar to the other one we did. So G is rotating along the polar axis on this latitude. You can see 65 degrees. So all you need to do, get the 2 pi r circumference of this latitude, get the length, then divide it by 24 hours. That is all. That is the speed. Then this other one says the radius of the earth is this. So we should find the length of the following parallel of latitude. So this is just to find the length of parallel of latitude. When the latitude is 76 degrees, get the length. You know, 76 degrees, the length of the circle will be different from the length of circle of 33 degrees. So that is it. That is the end of today's class. I hope you enjoyed it and you understand all we did. Just go through the video and you see that it's not a difficult thing we did today. So have a nice day and enjoy yourself. Bye.